Hi, I'm Bill Snodgrass, and in this lab experiment, it's an activity where we're going to use centrifugal separation to look at some fluids, some samples that we have that are. So we have some dirt that has been mixed into water. We have some salt that has been mixed into water. We have some coffee creamer, and then we have a mixture of. So we started with the copper sulfate and the sodium hydroxide, and we mix those together, and we come up with the reaction for this is in the description. So we end up with this mixture here. We're going to put them in the centrifuge, and we're going to test the hypothesis that these things are suspensions. And if they are suspensions, they will separate into layers, because a suspension is separable as a mixture. So the more dense particles, the centrifugal force will cause those dense particles, just like if you let it sit out in gravity. So we're going to go ahead and load the centrifuge. And very simple. The key thing is that your samples need to be approximately the same weight. It doesn't have to be like down to it depends on your centrifuge, of course, but for this one, if they're approximately the same weight, it'll stay in balance, it'll spin. We're going to turn the centrifuge on. Be very careful when you're using a centrifuge not to get caught in spinning parts, and that would be bad. Don't do that. All right, we're going to turn this on. All right, if you are doing this as an in-class activity, that is the setup. We're going to turn it on, and then after this spins, you'll turn it off, and then you'll get your own results. So when we get to the results section of this experiment, there'll be a slide in the video telling you you'll go do your own results and don't watch. So you just turn it on and let it spin. If you're doing this as a virtual lab, the results will come. And then if you are just like watching the video, if you're not going to collect data and come up with your own conclusions, the conclusions follow at the end. So we'll let this spin for a few minutes. All right, we're going to say that this is probably done. The effect of the centrifuge, the greater the difference in the density of the particles, the faster the centrifuge will separate them. Also, after you turn it off, leave it alone. Don't be sticking your fingers in there, because fingers are useful. So leave it alone. Let it spin down on its own. Be very safe when you're doing lab work. All right. So the next thing we're going to do is we're going to look at the results of the experiment, and then there'll be another pause in the video where you can do your results and then do your conclusions, and then the end of the video will be my conclusions. So we're letting this thing spin down. We're not going to bother with it. And it looks like we're probably okay at this point. So let's see what we have. All right, so this is the results section. So first out is the sodium chloride in water, and there is no separation. There's no separation in this sample. So the results on this would be there was no separation. All right, now this is the copper hydroxide sodium sulfate mixture here. And the copper hydroxide sodium sulfate mixture did separate into layers. So in your results, you're going to make that, mark that as separated. And now we have the coffee creamer. The coffee creamer did not separate. There's no separation in the coffee creamer. And then the last results would be the muddy water. So we have now the muddy water has separated. We have the solids at the bottom, and then we have a stained, more or less stained liquid. It might be a colloid. It might be a stained solution. So there's your results. So results 1, sodium chloride, no separation. Results 2, we have layers. The creamer, no layers, and the muddy water, we have layers. So those are your results. Now, if you are doing this as a virtual lab, you need to write your own conclusions and discussion, and that part, if you're just watching the video, we'll talk about the results. All right, so the results are that because there is no separation, sodium chloride is not a suspension. Now, it could be a solution or it could be a pure substance. We don't know. This test does not tell us what it is. It tells us that it is not a suspension. So the copper hydroxide sodium sulfate mixture did separate. So we know that that was a suspension. The creamer did not separate, and some people would say, well, if you spun it long enough, it would. And there's possibility there are some saturated, some large fat molecules that would eventually make their way to the surface. But in the amount of time that we spun it, it is homogenized, means homogeneous, means that it is not supposed to separate. That's the whole point. And finally, the muddy water was a suspension. And now we have this thing at the top, and then we have the stuff at the bottom. The stuff at the top, we're not sure what necessarily that is at this point, but it is the large particles settled to the bottom. Also, there's some small particles floating on top. So our conclusion would be not a suspension, yes a suspension, not a suspension, yes a suspension. That is it for this demonstration. Hopefully this was helpful. Hopefully this will let you see how centrifugal separation works, gives you some examples that you can use and kind of visualize that process, and understand that it only rules out if it only answers the question, is it a suspension or is it not a suspension? It doesn't tell us if it's a pure substance. It doesn't tell us if it's a solution. It doesn't tell us if it's a colloid. There will be other tests that would answer that. But this separates particles by their density. It'll separate a mixture. The densest particles will go to the bottom of the test tube. That's all. Thanks for watching. Click the like button, subscribe to the channel, all that stuff.